10 minutes.
10 minutes. After the second leg, what time did you have?
90.
And after the third leg?
130.
And how did you get 130? 40 to 90. So you just add on, okay? You need to make changes. If you don't have those numbers, fix it now. Okay? So that's, you started the stopwatch at the beginning of leg 1, and you let it run, and when they finished that leg, it was 10 minutes. But you kept it going, okay? And at the end of leg 2, when they were getting ready to leave, it had been 90 minutes. And then at the end of leg 3, you know, they left and then they arrived back home. At the end, when they arrived back home, the clock had been running for 130 minutes. Cool? Okay, now let's hop over here to displacement during leg. Okay, this is where we can use the equation xf minus xi, but you can also kind of logic it through. Okay, so leg 1 starts here and ends here. It goes 5 kilometers in the positive direction. So they travel, the change in position is 5 kilometers away from your start. So that leg 1 can be 5. Leg 2, they stay here. They start at 5, they stop at 5. There is no change in position, right? There is no delta t or delta x. So they stay here, so that could be 0. Now when they go back home, they're changing position in a negative way. Okay, they go from 5 kilometers position to 0 kilometers position. So if this is xf, 0 is xf, and this is xi, it's 5. Did I do that right? I'm going to have 0 minus 5.
Yeah.
This is a negative change. Okay, 0 minus 5 is a negative 5. That's different than total distance of travel. What's the total distance? How far have they traveled overall? 10 kilometers? Because they went here, they stayed, and they came back. So their travel is 10 kilometers. This number should be 10. The tricky one is leg 2. Leg 2, they don't add on any mileage. They just stay put. Okay? So after leg 1, they've traveled 5 kilometers. After leg 2, they have still traveled just 5 kilometers. They haven't advanced any further. And after leg 3, they went back. So they added on another 5 kilometers. Now let's talk about the graph. Notice the x and y axis and how it's labeled. Okay? So this graph is different than speed. We're not plotting distance and time. We're plotting position and time. Okay? Position is your x. So which column, hold it up and talk in your group and hold it up in your column. Which column are we going to graph for our y? Go ahead and discuss.
For the y. It either be displacement or position. Yeah, I say the.
We're not there yet.
Yeah, because. Yeah.
Yep, you. You're saying 3. You're saying 2. What do you guys say? We got 3 there. 5. Holy buckets.
Wait, how can it can't be 3 because column 3 is dealing with time.
Column 3 is dealing with time.
Position 1.
It's time interval during leg.
Oh, I'm sorry. The first column is the leg.
Okay,
The
well
second column
totally
is time. Yeah. The third column is position at the end of the leg x. Please discuss and readjust. Discuss and readjust.
I wasn't even talking.
We have the same one.
I see 3. I see 3. 3, 3, 3. What are you guys? You're 3? Okay. Yeah, I would say if we're just looking at symbols, this gives you the hint. We're graphing x. Okay? Now, it looks a little different. We're not doing speed. It's almost like our graph is going to tell us a story. The first leg is going to go up. The second leg is going to stay constant. The third leg is going to go down. So our graph is going to show us a change in position. Our graph will show us the delta t, but we are going to plot just x, just where we are at that time. So go over in your time, okay? Make your dot based on that third column, position x, okay? Then go over in time where your second leg ends, go over in time where your third leg ends, and you're going to connect them like this. Watch my finger. We travel in a positive direction. We don't change position. We travel in a negative. Ready, go.
So 1, so 5.
Your out of class practice is to finish this graph. Thank you.